Very good morning to everyone. Respected Honorable Chairman Dr. Ashok Ji Gujar, respected Honorable Vice Chairman Mr. Indrajit Ji Gujar, respected Honorable Secretary Dr. Madhuri Ji Gujar, respected Principal Dr. A.M. Mullah Sir, and respected Vice Principal of this institute Mr. H.M. Kumbar Sir, esteemed dignitaries, respected faculty members, and dear participants and my dear colleagues. On the behalf of G.K. Gujar Memorial Trust, Dr. Daulatrao Wahir College of Engineering, it gives me an immense pleasure to welcome you to this 6 days Atal FDP on academia synergy in disaster management and resilient infrastructure for advancing the sustainability. I, Rajguru Kamble, the Faculty of Civil Engineering Department, Dr. Daulatrao Wahir College of Engineering, Karad, it is my honor and privilege to address this auspicious gathering as an inaugural speaker. At the very outset, I would like to express my sincere gratitude to our respected event patrons for their visionary leadership, constant encouragement, and unwavering support in the organizing this meaningful academic program. I would like to take a few moments to remember and pay a tribute to Honorable late Dr. Madhu Kumthekar, who was the mentor, guide, and previous coordinator of this AICTE Atal FDP program. His sudden demise is an irreparable loss to our institute. Dr. Kumthekar sir was a visionary academician, a dedicated mentor, and guiding force behind the conceptualization and planning of this FDP. We humbly dedicate this program to his memory and commit ourselves to carrying forward his academic vision and the values. Before we begin the program, we take a moment to seek the blessings of Goddess Saraswati, the goddess of knowledge, wisdom, and learning. Let us all pay homage through the traditional Saraswati Pujan to invoke her blessing for a successful and insightful program.
या ब्रह्माच्युत शंकर प्रकृति सरस्वती भगवती ब्रह्म विचार सार परमा हस्ते स्फाटिकमालिकां विदधति पद्मासने संस्थिता वन्दे तां परमेश्वरीं भगवतीं सदां शारदाम्.
We sincerely thank AICTE for sponsoring this FDP and also truly privileged to have with us a distinguished panel of speakers of this program. They all came from across the nation and international platform, bringing with them a rich experience from both academia and the industry. Their insights, expertise, and diverse perspectives will greatly enrich our understanding of the disaster management and resilient infrastructure, and we are honored to learn from their valuable knowledge during this program. This program, which is scheduled from 22nd December to 27th December 2025, which aims to strengthen the synergy between academia and practice in the critical areas of the disaster management and the resilient infrastructure. In the era marked by increasing environmental and infrastructural challenges, the role of civil engineers in building safe, resilient, and sustainable infrastructure is more important than ever. Now, I would like to request our principal, Dr. A.M. Mullah sir, to address the gathering.
झालं. Respected management, all the distinguished participants, resource persons, and all my dear colleagues. A very good morning to one and all. So it's my pleasure and a sense of pride to welcome all of you on the inaugural session of 1 week ATAL FDP on industry academia synergy in disaster management and resilient infrastructure for advancing sustainable development, organized by the Department of Civil Engineering. At the outset, I extend my heartfelt gratitude to our management for their constant encouragement and support. The faculty development program now plays a very crucial role in the enhancement of academic research and professional competencies of teachers in the rapidly evolving leadership of higher education. Now, the continuing or continuous education is not a choice, but now it is a necessity. This 1 week FDT has been carefully designed to bridge the gap between the theory and the practice, promote the innovation in teaching learning process, and strengthening the research and industry oriented perspectives. We are truly fortunate to have with an eminent resource person who possesses rich academic experience and deep industry insights. Their valuable inputs and interactive sessions will undoubtedly enrich our knowledge and inspire us to adopt new methodologies in teaching as well as in research. I would also like to appreciate the enthusiastic response from the participants across various institutions. Your presence reflects your commitment to professional growth and academic excellence. On the behalf of organizing committee, I assure you that this FDP will be a meaningful and rewarding experience, providing the ample opportunities for learning, interaction, and the collaboration. Once again, I warmly welcome all the dignitaries, speakers, participants, and I wish the faculty development program grand success. Thank you very much.
Thank you so much, sir. With these words, I take a great pleasure in formally inaugurating this program and wish it a grand success. Let us work together to make this event meaningful and memorable. Now, I would like to request Professor Anisa Mulani, the co-coordinator of this program, to give an overview of this FDP.
Good morning. Respected dignitaries, distinguished resource persons, esteemed colleagues, and dear participants. A very good morning to everyone. I am Professor Anisa Mulani. On behalf of Dr. Ashokra Gujar Technical Institute, Daulatrao Ahir College of Engineering, Karad, it is my privilege to present an overview of this AICTE ATAL sponsored 6-day online faculty development program, scheduled from 22nd to 27th of December 2025 on the theme of Industry Academia Synergy in Disaster Management and Resilient Infrastructure for Advancing Sustainable Development. The primary objective of this FDP is to enhance academic and professional understanding of disaster risk reduction, resilient infrastructure planning, and sustainable development, which are critical in present scenario of climate change, rapid urbanization, and increasing infrastructure vulnerability. The FDP is systematically structured with 2 technical sessions each day, ensuring focused learning and effective engagement. After every session, the participant will be requested to submit their feedback through a Google form as per the ATAL guidelines, which will help us maintain quality and improve the learning experience. The program begins with the sessions on resilient infrastructure system and disaster preparedness by Sudarshan Bobade sir, Dean PCCOER Ravet Pune, followed by the risk assessment hazard mapping and disaster planning delivered by Dr. Shobit Saxena, sir from the University of Leeds, UK, bringing valuable international academic perspective. Transportation engineering for effective disaster management will be discussed by Dr. Sangram Nirmare sir, Assistant Professor, IIT Mumbai. Advanced technologies related to structural integrity and performance-based analysis will be covered by Engineer Chetan Raikar sir, Chairman and MD, Structural Designer. Consultant Private Limited, while earthquake seismology and earthquake resistant design principles will be addressed by P.K. Deshpande sir, a senior retired faculty. The FDP further covers geo-hazard risk analysis and landslide vulnerability assessment by engineer Aditya S. Gaikwad, who brings global industry experience. Institutional roles, governance, mechanism, and disaster resilient framework will be discussed by engineer Rajendra Pawar sir, based on his extensive involvement in flood studies and disaster management initiatives. Practical aspect of road infrastructure, resilience, post-disaster strategies will be delivered by Engineer Sambhaji Mane sir, Chief Engineer, PMGSY, Government of Maharashtra. While dam safety and disaster reduction practices will be covered by Engineer Deepak Modak sir, retired Chief Engineer, Government of Maharashtra. The program also includes the session on planning resilient urban and rural infrastructure by Dr. Sudarshan Bobade sir. The program also includes retrofitting rehabilitation techniques for enhancing infrastructure resilience by Chetan Raikar sir, and concludes with the integrated risk analysis and adaptive strategies by infrastructure system by Manish Kasar sir, technical territory manager, Ultratech Private Limited, combining academic insight with industry practice. Through this well-planned structure, expert-led session, and continuous feedback mechanism, this FDP aims to strengthen faculty competence, promote interdisciplinary research, and enable participants to integrate disaster-resilient concepts into teaching, research, and practical applications. I am confident that this FDP will academically enrich and professionally be rewarding for all participants. Thank you all. I wish everyone a successful and a meaningful FDP. Now I request Professor Ari Pawar sir to continue further. Thank you.
Okay. Good morning, everyone. I, Rajendra Pawar, Faculty of Civil Engineering Department, Dr. Daulat Rahir College of Engineering, Karad. It's my privilege and honor to introduce our distinguished resource person for the first session of this AICTE Atal Faculty Development Program, Dr. Sudarshan Sampatrao Bobade. Dr. Bobade is currently serving as a Dean of Research and Development and Associate Professor in the Department of Civil Engineering at Pimpri Chinchwad College of Engineering and Research, Ravet, Pune. He holds a doctorate in civil engineering from Savitribai Phule Pune University with a strong research focus on disaster management and religion infrastructure using geospatial techniques, carried out in association with ISRO, Indian Institute Remote Sensing, IIRS, with IRS, with 13 years of academic, research, and administrative experience. Dr. Bobade has made contribution to higher technical education, institutional research development. His area of specialization, including resilient and sustainable infrastructure system, disaster mitigation, geotechnical engineering, transportation engineering, and RS and GIS application. Dr. Bobade has an impressive research profile with numerous publications in Scopus and Web of Science Index, international journals, book chapters published by reputed publishers such as Springer. He is an active contributor to innovation and applied research, with several granted patent and registered copyrights to his credit. He has also been associated with a government-funded and industry-sponsored research project addressing critical infrastructure challenges in Indian context. He served as a resource person, expert speaker, trainer in numerous AICTE, ATAL, ISTE, and government-sponsored FDP, STTP, and training program for faculty and engineers. His professional journey reflects a strong alignment with the objective of AICTE ATAL, particularly in promoting quality education, research excellence, innovation, and sustainable development. The title of today's session, Excellence, Innovation, and Sustainable Development. Title of today's session is Resilient Infrastructure System, Vision, Challenges, Opportunity in India, closely aligned with his research vision and extensive professional experience. We are confident that his session will provide valuable insights into policy, perspective, technical advancement, and future research direction in resilient infrastructure development. Now, I respectfully hand over this session to Dr. Sudarshan Sampatrao Bobade and invite him to kindly share his knowledge and expertise with us. Thank you, sir. Bobade, sir?
Yes, am I audible? Thank you so much for such a wonderful introduction.
Yes, sir.
Just let me share my screen. I hope my screen is properly shared with everyone. Pawar sir, will you please confirm?
Yes, sir. Screen is visible.
Yes. Am I audible clearly and loudly?
Yes, sir.
Okay, thank you so much. So first of all, very good morning to one and all. Respected Honorable Chairman sir, Vice Chairman sir, Secretary ma'am, respected Principal sir, Vice Principal sir, Convener, Organizing Secretary, Coordinators, esteemed resource person, respected faculty members, dear researchers, participants, and my dear students. It gives me an immense honor and emotional fulfillment to stand before you today on industry academia synergy in disaster management and resilient infrastructure for advancing sustainable development. I sincerely thank the management and the leadership of GK Gujar Memorial Charitable Trust, Dr. Ashok Gujar Technical Institutes, Dr. Daulatrao Aher College of Engineering Karad for this opportunity. This institute holds a very special place in my heart. From 2012 to 2016, I had the privilege of serving this institution as the head of Department of Civil Engineering. These were not the just professional years for me. They were the years of learning, leadership, friendships, and shared dreams. My dear friends, the corridors, the classroom, the laboratories, and the discussions here shaped my academic and administrative journey. Coming back today in this role feels like coming home. So thank you so much for this opportunity. Respected dignitaries, in India, today the scenario is very critical, and we can say the India is stand at a critical juncture. Our infrastructure ambitions are bold, but our challenges are equally formidable. The climate change, the rapid urbanization, the extreme events, and the fragile ecosystem like the Western Ghats and the increasing socio-economic vulnerabilities are there, and that we need to face. So the resilient infrastructure is no longer the technical choice. It is a national responsibility, we can say. So it demands a vision that integrates engineering excellence, policy alignment, local wisdom, and the technology, and above all, the human sensitivity. However, before I proceed further, I stand here today with a very heavy heart. I am a proud student of late Dr. M.B. Kumtekar sir, my mentor, my guide, and a towering academic personality whose values shaped not just my professional career, but my way of thinking as a civil engineer and as a human being, especially. His absence today is deeply felt. Every time I speak on disaster management, resilience, and ethical engineering, I hear his voice guiding me. Sir, your teaching remains my strength, your values remain my compass, and your memories remain forever alive within me. Today, I seek the courage to deliver this session in your physical absence, knowing very well that you continue to guide us through your ideals, discipline, and the selfless academic service. You will forever live in my memories and in the countless engineers you shaped. Friends, this FDP is not merely a series of lectures. It is a platform to bridge the policy with the practice, the theory with the field of realities, and academia with the industries. So let us reflect deeply, question boldly, and collaborate meaningfully, because resilient infrastructure is ultimately about protecting lives, livelihoods, and we can say the future. So once again, I would like to thank the management, organizing team, and the ATAL for curating such a relevant and the timely program. I congratulate the Department of Civil Engineering for taking this leadership in this vital domain. With this word, now I take your leave to formally begin my session on resilient infrastructure systems, vision, challenges, and the opportunities in India. So let's start with today's session. Why this topic matters today? We all are aware that nowadays the India is experiencing the very highly increasing frequency and the intensity of the disaster, like floods, cyclone, heat waves, landslide, earthquake, and this posing very serious risk to infrastructure. Earlier, in last few decades, this particular disaster were rarely about to happen, but now their increased frequency and intensity shows that the human intervention playing a major role, and it is creating the devastating, yes, situation while handling the disaster, as our infrastructure has been designed only by the conventional ways, by considering only the standard designs, but not considering in detail the resilient and its impact thoroughly on future generation. My dear friends, when we are talking about the infrastructure, nowadays, whenever there is a failure of any infrastructure, it not only just what we can say impacts the routines, but it amplifies the disaster. Why I'm saying like this? Because whenever there is an infrastructural failure, whenever there is a weak infrastructure that has been constructed and created by the civil engineer like us, definitely the disaster, as it is supposed to happen, we can only predict the disaster, but we can't control fully. And that's why during such a disastrous situation, if our infrastructure is very well proven, if it is following the sustainability, if it is ready to recover, it is ready to what we can say mitigate with the effects of the disaster, then definitely there will be a less impact on the society. But as an infrastructure failure nowadays amplifies disaster, and during this there are so many consideration we need to take into account. While designing the infrastructure, we generally taken into account only the factor of safeties and the various cross checks that needs to be done way before is its actual creation on the ground. But it is the concern related to the disrupting mobility. It is the concern related to the water supply, energy, communication, and emergency response. So whenever there is a failure of any infrastructure, it is about to amplify the disaster, not only related to that particular disaster happened to the infrastructure, but also the direct or indirect concern related to the daily routines. And so whenever we are talking about this particular infrastructural failures, the main reason behind it is nothing but rapid urbanization, the climate change. Again, this is the gift given by human being to the humans, and the aging infrastructure, and which demands a shift from conventional strength-based design to the resilience-based planning and the system thinking. Now, what is resilience-based planning that we need to understand, and then we have to, yes, start our journey towards the, yes, futuristic infrastructural development. Now, when we are talking about this, the government of India at central and the state level, they are thinking on this particular topic since the last few decades. And now they came up with some strategies, policies, rules, and regulations through various studies they have done so far. So the building a resilient infrastructure is a central to the India's national priority nowadays. And so there is one beautiful term called as disaster risk reduction. Now try to understand, as we have very advanced technology available nowadays, we have the very premier institution available, we have very prominent research center available at India, and the very courageous civil engineers available. So they are thinking about the disaster, they are predicting the disaster by giving the proper weightages to various parameters those are causing the disaster at an actual. And on this particular basis of the study, they are identifying the risk. And risk is having the very beautiful terminology inside it. What does it mean? The this particular four words, risk, is nothing but, yes, first of all, we have to find out the knowledge and skill set available with us. If it is there with us, then we can easily implement to reduce, or we can say mitigate the problem that we are about to fix. So risk is itself giving us the suggestion that we need some skills, we need some knowledge, and that skill and knowledge needs to be implemented very properly to reduce or to damp or to mitigate the consequences or the impacts of disaster. So the disaster risk reduction framework is given by the central government is the nothing but the one of the SOP that we need to follow while constructing or while planning the infrastructural activities. The second one is the sustainable development goals. Nowadays, we all are aware that there are 17 sustainable development goals. And whenever we are talking about the sustainable development goals, the SDGs, every time we are only just understanding its theme, but we are not giving the true justice to that particular theme while constructing or while designing the infrastructure. And that is what the missing essence in between these particular goals. So for the future generation, if you could able to give some sort of gifts, that is nothing but the sustainable is living, what we can say, the nature. And that is what we need to consider while designing the infrastructure. At the same time, the government also have the great vision toward the Viksit Bharat, and they are planning to have the developed India up to 2047. My dear friend, when we are talking about the Viksit Bharat, during this particular progress or just enjoyment of this particular vision of Honorable Prime Minister, he's emphasizing on the sustainable development of the India. He's not only just asking for the infrastructure which is about to impact on the environment, but he's just expecting from us all civil engineers or the fraternity of the civil engineers that there should be the infrastructure development which will nurture the environment, which will help, which will protect the environment at a glance. Now see, this session will explore how India can plan, design, and manage the infrastructure that can anticipate the risk, withstand the shocks, adapt to the changing conditions, and recover rapidly and sustainably. Now try to understand, the risk will be there. Whenever there are disaster, there will be a risk, but how to just anticipate that risk, how we will be ready in a position to deal with that particular disaster, how we can able to readily and rapidly recover from that particular disaster, how there will be a speedy recovery of the infrastructure, how there will be a reduction of the risk, that we need to anticipate way before, and accordingly we supposed to be ready in position to deal with such a disasters in future. Now withstand the shocks, yes, there will be the many, what we can say, areas that needs to be considered, because due to the human intervention we are just uh, started disrespecting the mother earth, and so the mother earth is not in position to help us, to support us during the disaster because of our own mistake, and that we need to understand, and that we will discuss through a case study. Now adapt to the changing condition. Yes, the heat waves earlier in many metro cities, especially, the temperature was ranging in the range of, yes, 16 to 21 in summer season, but nowadays it is reaching up to 40 plus, and that is what the concern related to the global warming, and that we need to study and implement while designing the infrastructure. And yes, recover rapidly and sustainably. So there should be a solution, there should be an alternative design, so that we will supposed to start respecting the mother earth in a such a sense that mother earth will help us and protect us while dealing with the disaster. Now try to understand why there is a need for the resilience or the resilience infrastructure. On 13th October of 2025, the International Day for the Disaster Risk Reduction was celebrated with the theme Fund Resilience, Not Disaster. My dear friend, this is the very good opportunity for civil engineers like us, that the government is providing the fund for resilience. They are allowing us to go for the research. They are allowing us to think for the different material, different compositions, different mechanism and the technologies, so that we could have the good infrastructure that is sustainable, that is what we can say, helping us to just leave the vision towards the Viksit Bharat. So this particular theme we need to consider at a very large extent, that there is a support for the resilience infrastructure, not for the disaster. After disaster, there are so many concerns. There is a devastating situation which is about to impact the lives and the properties. But when we are talking about the resilience infrastructure, the concept is that invest into the infrastructure in a such a fashion that there will be a less impact on the lives and the properties, and that is what we need to consider here onwards. Because well within the conventional syllabus, though there is a autonomy, we are only emphasizing on the, yes, what we can say, the theoretical concept like design and the various aspect by following the ISOs, various standards and the IS codes. But here the need is to consider the thorough study in DPR, the detailed project report, in a such a fashion that the infrastructure will be resilient in itself, and that is what the need of time. Now see, there are two SDGs out of the 17. The SDG number 11, that is sustainable cities and communities. We all are aware that more than 50% of the population nowadays, they are residing in the cities, and because of that there is the concern and the activities, the human intervention, it is impacting on the climate, and that is nothing but the concern related to the climate change impact. As the 50% population is in cities, and there are the problem like rising temperature, there is the impact of the rising temperature on the sea levels that are disrupting the ecosystem, the food security, and overall the economies and the peace of the, yes, what we can say, society. So the climate change and its impact, okay, needs to be studied in very well advancedly. Now see, this is nothing but the SDG 13. So the 11 and 13, these two SDGs needs to be studied while designing the infrastructure. Now see, the environmental degradation and the disaster, we all are aware that there is an increased flood, droughts, famines and wildfires. Over the 2 billion people affected since 2000 at India alone. Now try to understand, this is the quite good amount, and when people are affecting means what? It is affecting directly or indirectly on the economy, socio-economical aspect of the any country, and that is what we need to understand. Now see the next one, urbanization challenge. Nearly 70% population will be there by 2050. So there is an urgent need for the resilient sustainable urban planning. And so while defining the vision for this particular topic, or we can say the resilient infrastructure, these particular studies are need to be taken into account. Next one is the global climate risk. We all are aware that nowadays every country in globe is experiencing the extreme weather. There is a quite noticeable sea level rise nowadays. Everywhere everyone is experiencing the habitat loss threaten all the countries and the living beings, and that is what needs to be considered while dealing with the infrastructural development. And so concluding with this particular slide, we can say at the end of this introduction of today's session that the bold policies are there, but we need to follow that particular policies for the resilient infrastructure, for the sustainable housing and the transport, and the climate adaptation and the mitigations are essential to reduce the future losses. Now see, in nutshell, when we are talking about the scenario related to the Indian territory, India is losing 2 to 3% in overall of the GDP annually due to the disasters. Now try to understand, when we are talking about the loss of the GDP, the gross domestic product, my dear friend, it is impacting everyone, every corner of the society with the greater sense. So the loss in the GDP means what? We are running behind. We could not able to achieve the set target or the set vision of Viksit Bharat by 2047. And that is what we need to, yes, reduce. So this particular leakage of the reduction or the losses of 2 to 3% of the GDP is in our hand. Being a civil engineer, we need to deal with this particular topic in that particular prospect. Now see, there are some direct losses. Yes, there are some direct, there are some indirect losses. When we are talking about the direct losses, which is everyone is experiencing in some or other way. Now try to understand the damage to critical infrastructure such as roads, bridges, buildings, power system, water supply and housing. When there is a critical infrastructural damage, definitely we start losing the revenue. We start losing the tolls and taxes. We start losing the levies. And that is what the direct loss to the society. Now see the next, when we are talking about the indirect losses, yes, the supply chain, the productivity loss, the increased public expenditure on the relief and reconstruction is again there. So see, already during the direct losses, there is a direct impact to the infrastructure, which we need to rebuild, retrofit, or what we can say, go for the alternative option related to that particular infrastructure services or what we can say the facilities available. In indirect losses, it is directly related to the bread and butter of the human being, and that is what we need to, yes, reduce. Now when we are talking about the 2033 alone, this calendar year January to December 2023, there was a loss of rupees 1 lakh crore, nearly equals to 12 billion US dollars, and this is only because of major flood and cyclone events. Now try to understand, the flood disaster or the cyclone disaster is not new to us or neither new to the globe. There is abundance of studies done on such a sort of disaster, but still we lost the 1 lakh crore rupees, and this is the significant amount because this is collected from the taxpayers. Now try to understand, when we are talking about the near, what we can say, nearby case studies, the 2005 the Mumbai flood and 2015 Chennai flood, this demonstrated that how infrastructure failures can escalate the localized event into the nationwide economic setbacks. We all are aware that Mumbai is nothing but the financial capital, and when we are talking about the Chennai, it is a IT hub. Both the cities, they not only impacted on national level, but there is a great loss in the international market due to the delay in some, what we can say, the MOUs, some business, some, what we can say, the development related strategies, and the people not believing when you are not able to sustain against the disaster, the natural disaster, and this shows that you are not well prepared to deal with such a disaster, and they are not ready to invest into our country, and that is what we need to understand in detail. Now in simply, we can say that infrastructural failures amplify the disaster. Now this is nothing but, what we can say, the hidden opportunity to understand this particular study in detail and need to just come back with some good sustainable solution, and that we will discuss in coming slide. Now see, by understanding this particular topic till now, we can say that the disaster don't kill, the weak infrastructure does. And my dear friend, that's why it's our moral responsibility or ethical practices needs to be followed at very great extent to just, what we can say, prove this particular concept that the infrastructure, the good quality infrastructure will definitely help us to recover, to, what we can say, remediate against the disaster. And so These are some particular case studies happened so far that we will discuss, and we will understand the concern related to such a sort of disaster and its impact on the society. Now, the Mumbai floods, every time the flood situation has been observed at Mumbai. In 2005, the flood was there, the devastating flood was there, and still we have not learned anything. And so in 2017 also, we have experienced the same. Now, what was the reason behind such a sort of disaster which are repeatedly happening, and at the same time they are controlling the complete, what we can say, the routine of any city or any, yes, terrain? Now see, the very first concern was inadequate stormwater drainage. Now try to understand, as I have already told you, that there are cities where the population movement for their sake of bread and butter is very great, and people are trying to go for, yes, the, what we can say, their own residences. And because of that particular grade, there is a great devastating progress in the infrastructure, especially in residential project. So what they are doing, as the Mumbai is having the very less, what we can say, the area to be get developed now and here onwards, and so they are going for the option like cover the drainages, fill it with the land masses, and then start constructing the residential project. So the inadequate stormwater drainage means what? Here, as a human, we are intervening in terms of the drainage. We are just trying to cover the drainage, and that particular covering of the drainage is reducing the stream numbers. And once the stream number has been reduced, what is happening is nothing but, though the stream order remains same for that particular drainage, but the number of streams in the lower order, say suppose there is a stream order of 7, so at stream order of 1, the number of streams will be get lower down, and that is resulting into devastating situation. We will discuss that with the help of the case study. So the encroachment of the natural drains leads to the prolonged urban flooding, and that we need to understand, being a civil engineer, how we could able to give the solution to such a sort of concern in near future. So during such a sort of flood, generally what happens, the transport paralyzes, the power outage is there, so the complete impact on the industry and allied area will be, yes, observed. Economic losses for the exceeding rainfall impact. So these are the concern. Then why we have not learned it? Because we are very much greedy, we are running behind the progress in terms of making the money and just enjoying the luxury, but we are not respecting the mother earth. And that is what we need to study, being a civil engineer, while constructing, while designing, or while approving the infrastructural needs of any society. Now, when we are talking about the Chennai floods, the poor reservoir operations, the blocked urban drains, and the uncontrolled urbanization was the major causes behind the Chennai flood in 2015. Now see, the poor reservoir operation, as we have the predictive model, we have the AI available with us, we have, yes, the great quantity and, what we can say, very great quality, good quality database from the IMD is available nowadays. So we can run the predictive models, we can able to just predict the rainfall, we can be able to design the stormwater drains, but still we have not done on that in that particular sector very well. And so the flooding, this particular flooding converted a heavy rainfall event into a citywide infrastructure collapse. So the concern was there was not adequate stormwater drains available, and whatever the available drains was there, they were blocked. And at the same time, uncontrolled urbanization, everyone would like to, yes, earn more and more, and so they are moving from, yes, rural area to the urban area, and that is the reason there is the devastating situation in handling, yes, solid and the, yes, related waste in cities nowadays. Next, the Kerala floods in 2018, sudden release of the water from the dams without integrated basin level management. The similar sort of things we are experiencing in Maharashtra in line with the Almaty dam. So whenever there is a no coordination, whenever there is a no proper study, whenever there is a no management, or there is a gap in communication, definitely this is supposed to impact on the upstream and downstream in, what we can say, the various ways. So the flood severity increased downstream, damaging the roads, bridges, and the settlement. So from such a sort of study, nowadays we need to understand there is an opportunity that we could able to study the reservoir well in advance. There are so many softwares available. We could able to understand the surface and subsurface drainages in detail way before. With the predictive rainfall data, we could able to understand. We could able to go for the sponge city sort of concept. We could able to create some wetlands where the excessive water will be stored, and accordingly there will be a control on the sudden release of the water during the flood situation. But still we are not working on that, and that is what the need of time in terms of the resilient infrastructure. Now, yes, we are enjoying the Ghat sections. The Himalayan and the Western Ghats are nothing but are one of the greatest and what we can say the beautiful identity in universe. But still we are unable to plan, construct the infrastructure by keeping into mind the feelings of the nature. So there is an improper hill cutting, weak slope protection is there, and inadequate drainage along the highways in day-to-day routine practices. While dealing with the subject like transportation engineering, we are teaching the students that along with the road alignment there should be the proper drainage system available. But whenever we are traveling on a road, for many of the roads there is a no proper drainage system available. So whatever we are teaching in terms of the what we can say the classroom theory sessions, they are not implemented at an actual on the ground. And that is the reason whenever we are traveling at a Ghat section during the rainy or the monsoon season, we can say there are always the concern related to the road failures in isolate regions. There is a delay in emergency response. Whenever there is a medical emergency due to the blockages of the road, the people are suffering a lot. At the same time, there is the concern related to the escalating of the casualties due to unavailability of the proper medical support during the disaster in such areas. The people are suffering a lot. And so, my dear friend, we need to study the landslide in detail. We need to understand the local terrain. We have to identify the various parameters those are causing the landslide, and we need to give the weightages according to the SATIS, one of the research article from 1980, that the weightage should be given to the parameter which will be the locally what we can say the local parameter should be considered while giving the weightages while going for the landslide susceptibility maps. Yes, the NRSC is supporting us, ISRO is supporting us. There is a too many the free data sets are available nowadays, but still we are unable to have the localized landslide susceptibility map. And so the B project, the MTech and the research studies should be aligned in this particular regards, because the resilient infrastructure will be designed on the basis of the landslide susceptibility maps of that particular local area. Now try to understand which sort of material to be used, which sort of what we can say the material composition should be adopted, which methodology needs to be adopted over there. These all question will be answered only when we will go for the localized solution. Now when we are talking about the cyclone on the east coast, there are so many cyclones recently happened, Amphan, Fani, and so many. So the vulnerable power networks, ports and the coastal infrastructure, they are the target. So whenever we are whenever there is a power outage, we are only saying and blaming the local transportation or what we can say local transmission systems. But there is a concern whether we are in position to give them the correct position, so that in futuristic cyclone cases, can that particular grid power network will be withstand with the cyclonic effect. We are what we are doing, we are only working with the design of the foundation. We are only working with the design of that particular power grid. But when we are talking about the local or the position based study for that particular cyclones, can we use the RS and GIS at a greater depth? Can we suggest them the location where they're supposed to build the towers? That is what need of time. And the next one is the coastal infrastructure. We all are aware that whenever there is a cyclone, it's directly impact on the maritime services, and so disrupted communication, there will be a delayed recovery during cyclones, and that we need to study in the greater sense while we are developing the resilient infrastructure. So we can say the disaster become catastrophic not only due to the natural hazards, but due to the non-resilient infrastructure system. So the non-resilient infrastructure, the conventional one, is nowadays termed as a non-resilient infrastructure. So what sort of aspect needs to be considered, what sort of additional features needs to be added into the design, that will be serve the purpose for the resilient infrastructure. So we can say that the hazards trigger the disaster, but the infrastructure failures decides their scale and the severity. So this needs to be understand. Now see what is the key difference between the traditional infrastructure and the resilient infrastructure. Now see, the traditional infrastructure is only strength based, but when we are talking about the resilient infrastructure, we are in need of strength. There is a requirement of redundancy. There is a understanding related to the adaptability of that infrastructure related to the futuristic disaster or the localized disaster. There are so many disasters at one single terrain. There may be the 2 to 3 different types of disaster happening in different season. So there will be an impact of the compound disaster as well. So that we need to understand well in advance. Next one is nothing but the intelligence. Now try to understand. We have the support, the great support from the ISRO. We have the so many satellites, those who are roaming, and they are availing us the too many data sets. Can we able to utilize that particular data set for the proper intelligence? Can we able to have the early warning system? Can we able to design the very robust system where there will be a good time for evacuation while the disastrous situation is there? So in nutshell, we can say that the infrastructure that can anticipate. So infrastructure should be like that. Yes, there will be there will be the probability of happening of the landslide, but the retaining structure will withstand. Why? Because it is already anticipating the landslide is about to be happen. Secondly, it should absorb the shocks, the sudden impacts of the disaster, because we can't withstand, we can't what we can say, stand in front of the nature, because we have our own limitation. Next one, it should be adaptable and rapidly recover. Try to understand, in resilient infrastructure, this particular 4 key features supposed to be studied before giving any solution as an infrastructure. So anticipation by that particular infrastructure, absorb related to the impact, adaptability, and the rapid recovery. Rapid recovery means what? I supposed to design, I supposed to think for the innovative infrastructure in a such a way that there will be few component needs to be replaced. After a while, when I supposed to replace that particular component in that particular infrastructure, the infrastructure will again ready to serve for his purpose. And that is what the need of the resilient infrastructure. So from disruptive events while continuing the essential function, we are expecting this particular few properties alongside with the infrastructure. Now see, as the topic name is related with this particular keyword, that is vision. Now vision for resilient infrastructure. Now try to understand how to draft a vision. Whenever we are drafting the vision for NBA, NAC, for our institute, our department, we are understanding all our strengths, weaknesses. We are considering the opportunities nearby. We are also working on the, what we can say, the challenges in front of us. So while defining the vision for the resilient infrastructure in India, we need to study few, what we can say, policy documents. So very first is nothing but National Vision and Policy Alignment is related to the DM Act 2005. Now try to understand, we are in 2025, at the end of the year, we are using the DM Act 2005, which has been formulated, which has been constituted by keeping into mind, yes, all the aspect of the disaster and the construction, what we can say, we supposed to do in line with this particular act. Here the prime focus is nothing but the lives, and that we need to consider as a, or what we can say, the final check. There should not be any harm, there should not be any impact on the living being. Now the second one is the National Disaster Management Plan, NDMP. So this particular NDMP has been formulated by considering the lacunas, by considering some, what we can say, the challenging situations in front of the civil engineer or the structural engineer or geotechnical engineer. So here NDMP will allow us to understand how to deal with the disaster, how to manage it. Next one, NIP, the National Infrastructural Pipeline. Here also the very good points they have yes, mentioned, that we will learn in next slide, yes, the coming slides. So first of all, the Disaster Management Act 2005. Now try to understand, this is the foundational legal framework for disaster risk reduction and the management. So way before in 2005, the government and the allied ministry, they started working on this particular framework by considering there will be a disaster, but how we could able to face it with the risk reduction sort of strategies and policies, and how we could able to deal with the management of such a sort of disaster, how we could able to recover from such a sort of disaster. So it mandates a shift from the relief centric response to the prevention, mitigation, and the preparedness. So DM Act is suggesting or emphasizing rather on how we could able to prevent such a sort of disaster, what will be the evacuation time available with us, what sort of the early warning system we can able to plan, what sort of the adaptable infrastructure we can plan, so that there will be a less impact on the monetary aspect as well. So this is nothing but the prevention point they have mentioned very clearly in DM Act, and that we need to consider while preparing the DPR. Mitigation is the meaning of the mitigation, to reduce the impact, and accordingly we need to have the infrastructure which will mitigate the impact of the disaster and which will safeguard the lives and property in future. And the preparedness, yes, we should be in position to have the proper task force available with us, so that we could able to just deal with such a sort of disaster at any instant. That is what we are in need of. Next one, the act emphasizes on risk assessment and vulnerability reduction. So there is a great, what we can say, the initiative, there is a great potential in this particular area, gray area rather. The government is availing us through NRSC the many free data sets, but still we are not able to download it, we are not able to process it, and we are not able to utilize it while designing the infrastructure, because we are in mindset that the infrastructure should be designed by keeping into mind only the IS code, but we are not considering the sustainability. So the risk assessment and the vulnerability reduction should be the integral part while designing the infrastructure. Now mainstreaming the disaster resilience into the infrastructural planning and development. Now try to understand, whenever we are planned, there is a very beautiful quote by the Vishwas Nangre Patil: if you fail to plan, you are planning for your own failure. And that is the reason, whenever we are going for the NBA, NAC or sort of accreditation, we are believing in the PDCA cycle, plan, do, check, act. And here we need to just emphasize on that particular cycle, that infrastructure should be planned and developed by considering its disaster resilience ability, and that is what needs to be studied locally. We need to study that particular area in detail, not only considering its zone, not only considering the past happenings, but by visiting that particular area through remotely or physically, and in that particular sense collecting all the database required for the design of the infrastructure. Now see, for infrastructure, when we are talking about the roads, bridges, dams, buildings, and the utilities, they must be designed considering the hazard risk. So every time whenever we are visiting the Konkan region, western Maharashtra, we came across the many bridges. During the rest of the time, apart from the monsoon, the river or the drainage is having the very less flowing through it. But during the flood season, there will be a great shocks supposed to be, yes, experienced and observed and withstand by that infrastructural facilities. And so this particular hazard risk consideration should be well studied when we are designing such a sort of, yes, infrastructure. Safety and resilience are the statutory responsibility, and they are not at all the optional measures. Being a civil engineer, many a times we are neglecting the statutory responsibility in line with the safety and resilience, and that supposed to be the mandatory cross check while designing the infrastructure. Now infrastructural resilience become the legal and governance obligation. So everyone knows now that when I am constructing any infrastructural facility, say suppose transportation facilities, say suppose road, I supposed to take care of that road facility for minimum 3 rainy season. And so sort of things nowadays, through legally or through the governance obligation, they are making mandatory to be followed. And this is nothing but through the Disaster Management Act. So while defining the vision for this particular infrastructural resilient infrastructure, we need to thoroughly study the Disaster Management Act 2005. Next, the NDMP. Here, try to understand this particular NDMP operationalize the Disaster Management Act at various levels. So national level, state level, district level. So try to understand they are percolating their strategies, policies, rule, regulation to different level. Through district level up to the local, what we can say, the area basis study, there is a great gap, and that we need to, yes, sum up with, and that is nothing but the responsibility of the civil engineer nowadays. Now see, the resilient infrastructure development, use of hazard resilient construction practices, and the integration of the climate change adaptation. These are the three key features NDMP is expecting from us. And so here the climate change and its impact on the, yes, upgoing infrastructural projects, hazard resilient construction practices, whatever happening at the global level, that needs to be studied, that needs to be well understood and implemented at the locally, and that is what the need of the time, because we are going with the very traditional studies in the BE project, ME project, or dissertation, and the PhD studies as well. Nowadays this is nothing but the additional area that we could able to add with. Now, adapting the Sendai framework principles, yes, this framework is available since so many decades, but no one is following this particular framework, and that is why we are suffering with the, yes, the investment we have made in the infrastructure. As if there is a failure of single bridge, if there is a failure of any newly constructed road, it is directly about to impact on the taxpayer's pocket, but no one is respecting the taxpayer, and that is why whatever we are doing, if we could able to follow the Sendai framework, definitely there will be a less impact on the taxpayers, what we can say, pocket. Now see, first of all, we need to understand the disaster risk. What is risk? I have already told you, risk means what? It is a reduction by implementing the skill and knowledge. So how we could able to just reduce, or there will be a reduction in terms of the impact that we are about to, yes, experience, is by implementing, integrating rather, skill and the knowledge, and that is what we need to study. Next, strengthening the governance. Yes, there should be a proper communication, as we have seen in the case of the Almaty and the Koyna dam. There will be always the communications related concerns, and there will be a disastrous situation afterwards. So the governance training is very much important. Investing in resilience, as this year theme is fund for resilience, not for disaster. This is very true in sense that there should be the investment requirement for the resilience, and at the end, enhancing preparedness, that is build back and better. Try to understand, we could able to build the infrastructure well within very less time. It should back, it should able to just sustain with the futuristic impact with the same strength it was planned and designed at the very early stage. And it should be the better, it should have the better early warning system, it should have the better functioning and efficiency afterwards, once it is retrofitted or it is repaired or reconstructed. So that is what the need of time. Through Sendai framework, we came to know about this particular parameter. So this is supposed to be included while designing the infrastructure. Now see, the infrastructure planning must be risk informed, multi-hazard, and the life cycle based. The risk informed means what? Every time we could able to identify the risk parameters, and accordingly we could able to assist the society. Multi-hazard, yes, I have told you that many areas are there in Maharashtra where they are experiencing the landslide, they are experiencing the earthquake, they are experiencing the flood. So multi-hazard related preparedness of the infrastructure in itself is very much important. And the life cycle based, do remember, whenever there is an investment of one single rupees, there is an expectation from the society end. Whenever there is an investment, means what? We are not able to utilize that single rupees for other project, for other developmental activities. And so if there is a loss of such a sort of investment in terms of the infrastructure during the disaster, we are about to just, what we can say, losing our potential to have the other additional facilities in terms of the infrastructure for the coming generation. So this is our moral responsibility to understand the life cycle of the infrastructure as well. Now see, the next one is the National Infrastructural Pipeline, NIP. Now when we are talking about the National Infrastructural Pipeline, NIP is India's long-term investment roadmap for infrastructure across the transport, energy, water, urban development, and the digital infrastructure. And here, massive capital investment is there for protecting the assets from the climate and the disaster risk. So what they are suggesting that protect your assets against the risk, associated risk in line with the climate and the disaster. There should be the reduction. There should be the reduction in the future economic losses through this particular investment. So invest in a such a, what we can say, invest into such a alternatives or the solution so that there will be a less impact on the futuristic economic losses. So NIP is asking us, requesting us, insisting us to plan and have the DPR by considering embedded resilience into it. So design should be likewise. So there should be avoid the costly retrofitting latter. Try to understand if infrastructure fails and we are investing again for its retrofitting, its what we can say repair and reconstruction, then it is none of anyone's business. So it is always better to invest in such a fashion that it will be withstanding with the impacts, because we have identified the risk in well manner. So resilient infrastructure is essential to protect the national investment and the economic growth of any nation. Now, Gati Shakti Master Plan. This is one of the very important parameter. Nowadays, the civil engineers, they are refusing, they are reluctant to learn the various languages, the computer languages, the C, C++, Java, .NET, Python, R. They are not at all ready and they are not at all positioned to deal with such a sort of studies. And that is why we are losing our potential area of, yes, what we can say, the employment. Try to understand whenever there is a SIH, Smart India Hackathon, all the problem statement, they are related to the society. Society means civil engineering, and still these particular problems are belonging from our territory, but still there is a requirement of interdisciplinary study or the approach. As we are not training the students, as we are not ready to adapt with the changes of the progressive era, and so we are not having the good hand in the various languages, and that is why we are not able to use the RS and GIS at a greater extent. So the multimodal GIS-based integrated planning platform is required, and that is what suggested under Gati Shakti Master Plan. Now see, the breaking the silos between the ministry and the sectors by enabling the coordinated infrastructure development and the spatial data driven decision making. So nowadays ministry also believes that there should be the study of that particular infrastructural project well in advance by using some RSGIS based platform. And so there will be a good coordination in between the various ministries. There will be a less delays when I'm taking into my hand any project. There will be a good support from the ministry level, because they are aware about the progress of the project, they are aware about the futuristic concern, they are aware about the concern related to the land acquisition and yes, various parameters. They are aware why we are changing, why we are shifting, why there is a need to shift the alignment. There is a square phenomena, that is safe, short, easy and economic sort of things will be studied, will be emphasized, will be discussed with the ministries at a greater extent, and that is what we are in need of. Next one, the resilience perspective. When we are talking about this, it helps avoid infrastructure placement in the hazard prone zones. Now try to understand, the NRSC is giving us helping hand with some typical parameters and its weightage assignment for various disaster. They have prepared the disaster plans for various zones. I would like to show you afterwards during this presentation. So they have already prepared the landslide susceptibility plan for complete nation. But try to understand, whenever they are preparing this particular plan, they are giving some weightages as per the, what we can say, country level or the central level parameters they are handling. But when we are dealing with the localized concern, there should be the change in the weightages assignment, and that we need to understand. So already there is one plan available. I could able to prepare my own plan. I could able to match it with the earlier available plan, and I can able to just identify the differences in between this particular study. So this will help us to understand where we need to place the infrastructural activities, where the infrastructural project should be happen. So hazard prone zones we could able to identify, and we could able to share with the local authorities. Next one, the enables the better alignment of the transport, utilities and the logistic network. I have already told you the principle of S square is square, short, safe, easy and economic. This is the very simplest phenomena any ministry is expecting from us. Why? Because there is a concern related to the resources like main material machinery, material money and machinery. Apart from that, the very important resource called as time, and that is why we need to understand this in detail. So the Gati Shakti master plan, this particular scheme, just asking us to promote the system level resilience instead of isolated asset development. So this is what we need to understand. There should be approach which will be the system level resilience. Now the next one, Viksit Bharat 2047. While defining the vision, there is a need of so many documents we need to follow, and that's why we are discussing in this particular documents in detail. Now see, the India's long-term vision to becoming a developed nation by 2047, everyone knows about it. So how the nation will be converted from developing to the developed state. Now see, there is a clear cut, what we can say, discrimination between the economic growth. There should be a good economic growth. We need to, yes, achieve urbanization and the infrastructural expansion. They are nothing but the core pillars. So this particular three parameter needs to be understood well in advance while going for the resilient infrastructure. Next, when we are talking about this, the frequent disaster can reverse the development gain. So try to understand, from 2025 to 2047, if there are the what we can say, unfortunately, the on large or the great extent, with the great intensity and magnitude, some disaster happens and they disturb the available infrastructure, existing infrastructure. Definitely our vision to become a developed country by 2047 will be delayed, and that is what the reversal of development gains that is supposed to happen if there is a no resilient infrastructural available. So here Viksit Bharat is focusing on sustainable growth, ensure the infrastructural longevity, so durability, workability, everything we need to consider under DPR studies, and protect vulnerable communities. So we have to identify the vulnerable communities first of all, and then we have to think for the resilient infrastructure. So the developed India must have disaster resilient and the climate resilient infrastructure. That is what the very, what we can say, the limited expectation from our end, from society. The next parameter is Coalition for Disaster Resilient Infrastructure, CDRI. This particular booklet will allow us to understand our global level presence. So global initiative led by the India. Nowadays, we are not only the followers, but we are suggesting some good paths for as other countries to be followed in terms of the disaster management. So the knowledge sharing and the best practices, the technical support for the resilient infrastructure, and capacity building and research collaboration, these are the gray areas touched through the CDRI. So here positions the India as a global leader in the resilience thinking, not just a beneficiary. That is what we are expecting from everyone who is attending this session. So our contribution should be like that. The other countries should take the, what we can say, the footprint from us in terms of the development of the resilient infrastructure. So India is shaping the global standards and practices nowadays in resilient infrastructure. So in nutshell, we can define the vision that to build the infrastructure that should be the smart, that should be the safe, sustainable and survivable under the multi-hazard condition. Now try to understand under multi-hazard condition means what. Here we have to just integrate various IS codes, various theories, and we have to prepare another theory which will withstand with this vision. So the India's vision for the resilient infrastructure is not fragmented. It is deeply embedded across the laws, policies, investment plans, and the global leadership initiative. Part first of today's session. Now try to understand how we could able to survive with this particular vision, how we could able to enjoy this vision to reach up to the mission and to have the fulfillment towards the our short and long term goals of the nation. Now there are few areas that we need to study in detail. So civil engineering, specifically in civil engineering, though with the multidisciplinary approach we could able to, yes, give the solution to the problems we are about to face in the resilient infrastructure, but there is a need that we supposed to now start learning some advanced tools and technologies so that we can able to withstand with our own domain. Now see, at urban level there is a need of sponge city, climate adaptive drainage. Now what is sponge city? Sponge city means what? Whatever the rainfall we are expecting, that's supposed to be handled very carefully. There should be the proper storm water drainage system. There should be, yes, properly designed drainage system. There should be the surface and subsurface drainage, what we can say, management in very proper way. And there should be the, what we can say, the runoff should be handled in a such a way that the water will not supposed to be raise its head and convert that particular excessive rainfall in terms of the runoff, in terms of the flood, and which is about to impact the city. So sponge city means what? Here we need to understand the geography of the area. Where is the low lying area is there, what sort of strata is available, from where the water will be easily drained and it is supposed to be get merged with the main stream or drainage, and it is easily okay moving ahead without disturbing the city. So that is what needs to be studied. Next one, the energy. Yes, we could able to extend our helping hand to the, yes, Maharashtra State Electricity Board in our case, and here transmission section will be majorly helped from our end by understanding the grid resilience. So the grid resilience, this is the interdisciplinary study with the electrical engineering fraternity and renewable energy sources. These particular projects will be handled by giving some solution in terms of the resilient infrastructure. Now digital, when we are talking about the digital sector, how we can able to enjoy this particular vision. So the infrastructural intelligence, whatever infrastructure we are constructing, if it is AI based, IoT based, or it is what we can say GIS enabled, definitely we could able to understand the, what we can say, the impact of disaster on that infrastructure. At the same time, we could able to understand its workability, functionality, the impact, the methods of the recovery, retrofitting, and everything in while what we can say expecting the speedy recovery. So the digital what we can say essence should be added to the infrastructure in greater sense. Next one, water. When we are talking about the water as a resource, there should be decentralized GIS based water resource management. So always try to understand every sector should have one particular interface. That interface will serve the purpose of that particular sector. Say suppose there is a release of the excessive water from dam, then dam authority will have one interface where they could able to understand the impact on the downstream area. At downstream area, say suppose there is a gram panchayat, there is a one panchayat samiti or sort of administrative blocks are there, they could able to understand that particular, yes, release water and its impact on the, or in line with, in alignment with their own, what we can say, the safeguards in terms of evacuation of some communities from low lying area, in terms of the availability, whether there is a proper availability of the drinking water available with them, whether there is a great impact on the, yes, blockages, or what we can say, the outages of the power failure. So sort of things will be there. So integrated study and applications should be available with the water sector. Now when we are talking about the transport, there should be the flood and landslide resilient roads and bridges. So whenever we are designing the roads or the bridges, they are not only constructed by keeping into account the subgrade strata, the bearing capacity, the highest flood level, but they supposed to deal with the futuristic flood and the landslide. That is what we need to understand the sector wise in the resilient infrastructure. Now see the multi-hazard landscape of the India. First of all, we will try to understand the India's hazard profile. Now see, when we are talking about the flood, the 40 plus millions hectares area till today is vulnerable under flood. So we need to identify from our own localized area which area is still unattended in terms of the flood disaster, how we could able to sustain with the development of the infrastructure in that area, and accordingly we could able to help the governance in terms of just going for the additional infrastructural requirement. When we are talking about the earthquake, the 60% landmass is still posing the risk associated with the earthquake with the various zones. When we are talking about the cyclone, as we have the coast on east and west side, at both the sides there is a probability of cyclone disaster. So how we could able to give the solution to them? When we are talking about the landslide, yes, Western Ghats are there, Himalayas is there. So we need to study this particular territory in detail in terms of the resilient infrastructure. When we are talking about the heat waves, I have already told you by 2050, the 70% of the population will start residing into the cities. And that is why there will be impact on the climate change. And heat waves will be the permanent disaster that's supposed to be faced by us in future. And that's why urban India needs to be studied in detail. When we are talking about the flood, now I would like to give you one particular example of the flood. Now see, this is the atlas prepared by NRSC. Okay, for this study has been done for the calendar year 1998 to 2022. Now see here the list of frequently used satellite and sensor for flood mapping. Now see, this is 179 pages booklet in which everything has been mentioned very thoroughly for all the states. They have identified the various areas and sectors where the flood probability is there. So what we need to do, we need to integrate the AIML. We need to go for, yes, the various advanced studies using the AIML. Can we have the different weightages to the various parameters they have already defined? What will be the impact on the, yes, the flood disaster map for that particular area, that we could able to understand. So these are nothing but the various resources. Okay, so these are the satellites with the various range of sensors and the spatial resolution they have mentioned. So this data, this sort of PDFs, what we can say, the study data, the reports we need to follow while going for the higher study. When we are talking about the, yes, next parameter, now see the methodology for satellite based flood inundation mapping and monitoring. So everything is been mentioned over here, how the optical satellite data and its availability is there, how we could go for the geocoding with the master data, image enhancement will be there, so classification, pre-flood and permanent water bodies, so sort of things, methodology is also there. We need to only follow this particular methodology. We could able to add some parametric basis studies which is locally, what we can say, very much important, and we could have the enhancement to the methodology, and we could able to get the very good, what we can say, the efficient maps for flood disaster in future. Now see, at the last I would like to show some particular parameters. So for Maharashtra, flood affected areas atlas of Maharashtra, if you could go ahead, we could able to understand at various years, 2005, 6, 13, all these particular years, how the various state district there, district has been affected, how much area has been affected, and this is nothing but the map they have prepared. So locally we need to study the flood inundation map in great sense. So this is related to the floods. Now for earthquake, yes, there is again the one particular technical report. Okay, the working committee of the expertise, they have prepared under the National Disaster Management Act, NDMA, okay, authority, they have prepared this beautiful study. Now when we are talking about the cyclone for the east and west coast, there is again many reports available where we could understand the how we can able to predict the futuristic cyclone, and accordingly how we could able to plan the location of the various infrastructural projects in near future. So these particular studies are important. When we are talking about the landslide, now try to understand, when we are talking about the landslide, there is a complete maps, okay, for different yes, states they have prepared. So this is nothing but the landslide map. So they have studied for 2014 to 2021. Now we could able to have the reference of these particular documents, and we could able to prepare the DPR by understanding the probable location. There is a two-way approach. First, we could able to just go with this particular available report, or there will be a possibility that if you are having good hands in RSGIS, you could go ahead and you could able to study this particular area in detail for the localized, what we can say, the terrain, and accordingly you can able to suggest the infrastructural development projects in future. So this needs to be studied in detail. I would like to share these particular PDFs with the organizing committee so they could able to drop the same with same in your WhatsApp groups. Now see the compound disaster. Now try to understand, there are so many disasters, the flood, landslide, infrastructure collapse. So all these are treated when they are having the impact one after another. So they are treated as a compound disaster. So the climate change as a risk multiplier is playing a major role. So we need to again think for the best practices to be followed being a human being. And specifically for Western Maharashtra and Konkan, these compound disasters are impacting very badly. Now, when we are talking about the multi-hazard map of Maharashtra, try to understand when this SDMA, the State Disaster Mitigation Authority, they have just prepared such a sort of maps through the various studies. So the multi-hazard map of Maharashtra here, the maximum hazards that are ranging from, yes, 2 to 8. So 8 hazards are happening in a same district or the terrain. So such a sort of areas needs to be studied in great detail before suggesting any infrastructural development. And that is why there is a clear-cut indication that not only the IS code but also the DPR should be prepared by understanding the sustainability goal. So this is multi-hazard map of Maharashtra. This is drought frequency index of Maharashtra. There's then seismic risk and historical earthquake events, flood inundation, landslide sensitivity, lightning flash density, and the wind classification and major cyclonic events in Maharashtra. Now, such a sort of maps are there, such a sort of study has been there. We have to only use such a soft data while going for the additional studies for the localized terrain. Now, what are the key challenges in the building resilient infrastructure? So there are 4 category of the key challenges we will learn one by one. So first one is nothing but technical challenges. Now try to understand under technical challenges, what we generally lag with is the design codes not fully hazard integrated. The design codes are conventional one. They are just the guide we are following to design the infrastructure, but they are not taken into account the hazard and related, what we can say, impact. And so hazards, the disasters, they are different during different season. They are differently acting during different climatic condition. So they needs to be studied and integrated study should be happen. So design code not fully hazard integrated. So how we could able to enhance the design code, how we could able to add some amendments into it, being a researcher, being a faculty from the civil engineering, that is the need of time. And so the IS code and a few amendments required into it related to the disaster is nowadays the need of time. Next one, poor operation and maintenance practices. So whenever we are talking about the drainages, there is a stormwater drainage management or other water drainage management are there. Whenever there is a concern related to operation and management, definitely this technical challenge will just what we can say allow us to get trapped into the disaster itself, because every year what we can say way before the monsoon season start, Mumbai municipality, the BMC, is always floating some tenders to clean the drainages, but we all are aware that what is the actual scenario and why they are, though they are cleaning the drainages, okay, but still they are unable to serve the purpose. Why it is happening? Because they are just change the natural drainage system. They are not given any alternative to the natural drainage system. So there is a great requirement, there is a gray area rather, how we could able to give the, yes, the what we can say, the uh, rejuvenation to the alternative for the natural drainage, which are already covered by the infrastructural what we can say facilities available. So this is nothing but the gray area we need to study. Lack of performance based design. Now see, till date whatever we are designing, we are designing by keeping into mind that there is some typical factor of safety, but we never ever design any infrastructure so far by considering the performance. So there should be the study in terms of the simulation, validation, everything way before it has been start what we can say executing on the real ground, and that is what required things. Now, aging infrastructure, flood and landslide resilient roads and bridges. You might be surprised that the British government share one particular what we can say letter with the Karad Nagar Parishad, stating that one of the bridge constructed by them is not now here onwards no longer able to serve without retrofitting and the repair or the maintenance required for the bridge. So we need to just go for the surveying the available infrastructure. we need to understand the impact of aging, we need to retrofit it, and accordingly we need to deal with the technical challenges in front of us. Next one, there is another challenge called as institutional and governance challenges. So the very first point is weak enforcement of the code. Okay, so weak enforcement of the code many a times at many area where the people are not interested to invest into their future, or they are not ready to share the good resources to their next generation. They are not following at all the codal provision. They are going with the traditional way. They are going with the untrained, or what we can say, the labor based practices for construction of the infrastructure. That might be the residential project, that might be the any other project. So the weak enforcement of the code is one of the reason under the institutional and governance challenges. Next one, the fragmented responsibility. We all are aware that during fragmented responsibility, everyone is come with their own motive. They will about to serve their own purpose, and afterwards there is a, yes, as no one is responsible for that particular act. So whenever there is a disaster, there is a great impact, because they don't have the common vision, they don't have the common vision to enjoy. And that is the reason, whenever there is a fragmented responsibility, there is a maximum percentage of the probability of happening or recurring of the disaster. So whenever there are various stakeholders, what we can say, the services stakeholders are involved while erecting any infrastructure, they should have the common motive, they should have the common understanding behind the construction of that particular infrastructure, and that is what needs to be understood. And after the disaster, post disaster reactive approach. So post disaster reactive approach, all the sort of services from the health sector, from transportation, from governance, from what we can say law and order, they're supposed to work hand in hand. That is what missing. And so sort of database, this coordination is missing because there is a lack of coordination related to the infrastructure and related aspect. They are not at all aware about the infrastructure, its failure and its impact on the society. If every sector is well versed about such a sort of tragedies is supposed to happen in future, then what will be the impact, how they supposed to keep themselves ready to deal with such a sort of tragedies, then needs to be considered under the institutional and governance challenges. Next one, the key economic challenges in building resilient infrastructure. Now see the balance. Whenever we are investing into resilience, though it seems to be costly, but it is having some perception. Here we are giving the good resources, good facility for the coming generation. But whenever we are talking about the lack of life cycle, its cost, when we are talking about we are not considering the renewable energy, when we are not considering the sustainable infrastructure, definitely there will be imbalance. So the resilience cost and the life cycle cost, there needs to be balanced very properly, and that is nothing but the another challenge of balancing the cost and the resilient infrastructure, because conventional infrastructure and resilient infrastructure, they are differed greatly in terms of the economic aspect. Next one, the key data and technology gaps in building. Now see the poor integration of the academic research. Many a times the research is only limited for the sake of the degree. It is not shared with the local authority, it is not shared with the respective governance, and that is why whenever we are having any research related to that particular area, being a civil engineer, it's our moral responsibility that we need to discuss that research with the local authorities. We need to share that particular knowledge with them. Under utilization of GIS, RS and AIML, yes, we are lagging in this area because we are not having good hand in the various languages. No one is ready to adapt the changes, because change is only constant in universe, but still no one just believe in this particular phenomena. And so the civil engineering syllabus is not including such a sort of, what we can say, the additional uh, training for the student, and students also hesitate to learn these particular languages. So there is the great scope for the civil engineering student to learn the various languages and utilize that into RSGIS and AML study. When we are talking about the real time data at India, you might have enjoyed the movie Deud Band, in which there was a clearly mentioned by that scientist that the whatever the data receiving time we are required at India, okay, and the processing of the data and giving the AI, giving back the early warning system. So sort of technology needs to be yes, what we can say, enhance, sharpen in detail. So there is a great scope that how we could able to deal with the real-time database. Now next one, the limited real-time data. When we are talking about it, there is a improper, what we can say, coordination between the various uh, agencies in terms of gathering or collecting the data and processing it for the disaster resilience, or what we can say, the disaster recovery. So that is what lagging. So this particular thing we need to study. So India does not suffer from the lack of policies, my dear friend, but from the lack of integration and implementation. So this integration and implementation is required from our end. Now what are the opportunities? There are so many opportunities. They are about to be get what we can say, turning challenges into strength. This is what we need to understand whenever we are looking toward this particular picture. See, this is what the India should be in what we can say, the vision of any civil engineer. So policy and institutional opportunity, we all are aware that there is a CDRI leadership is there, smart cities mission is there, Jal Jeevan mission is there, Pradhan Mantri Gram Sadak Yojana is phase 3, climate resilient road specifically, they are there. So that we need to understand in detail. Now CDRI leadership, now how much time is there for me? Anyone please confirm from now onwards how many minutes I do have. Hello, am I audible? Hello.
15 minutes more, sir. You can continue.
Okay,
Or
thank you.
actually, you can take as long as you want. No worries.
Oh, thank you so much. So now see, the Coalition for Disaster Resilient Infrastructure. India is not just adopting resilience, but leading the global agenda through CDRI. So I have already told you that the knowledge sharing is there, global best practices, capacity building for resilient infrastructure. But here, what we need to do is, being an Indian institution, engineers and researchers, we have to collaborate internationally. We have to influence the global standards. We have to give the access to resilience framework and funding support. So at nutshell, we can say that India is shaping how the world thinks about resilient infrastructure, not merely following it. So we need to deal with our own disaster with our own, what we can say, the remedy, and that is what the need. Now smart city mission, try to understand, when we are talking about the smart city mission, it is not merely related to the only luxury life. It is not really merely related to the parks and recreational center, but it is nothing but the integration of the technology, data and the resilience into urban infrastructure. It is there, it should be there for improving the urban services under the stress condition. So whenever there is a flood, heat waves or power failure, many a time the people are suffering a lot from such a sort of disaster. So that particular, yes, emphasis of disaster on the human being should be get what we can say, mitigated, should be get dampened very properly. So this is nothing but the smart cities mission. Now in the smart city, there should be a proper system in terms of the drainage, so that there will be a flood monitoring, real-time data for traffic, water, energy. This should be included under the smart city mission. When we are talking about the ICT enabled emergency response system, that is the requirement of the smart cities. And for that, we need to study the city in detail in terms of the geology, in terms of the geography, in terms of the, yes, the futuristic infrastructural project. So the smart cities are not only smart in services, but smart in surviving and recovering from the shocks. So smart city means what? Take an example of the Dubai. In last, what we can say, I think way before 3 to 6 months, there was a great, what we can say, flood at Dubai. But well within 24 hours, the city was recovered, as it was not, as there was no such a sort of activity happened before 24 hours. So sort of, yes, infrastructural facilities should be there, and for that the civil engineering brains are required. The next one, the Jal Jeevan mission. Now see, Jal Jeevan mission focuses on safe, reliable and the sustainable drinking water supply. So first, safe, yes, it is the part and parcel of environmental engineering. Reliable, just like a Toyota, whenever till date no one has seen any Toyota vehicle stopped in between any journey, and they are worried about the mechanical, what we can say, the failure of the vehicle. There might be the concern, they are just the sort of wear and tear sort of thing. So the reliability of the Jal Jeevan mission, this is in our hand. If it is reliable, definitely what will happen, during the disaster there will be a less impact on the society, and they are not suffering through such a sort of unavailability of the natural resources, like, yes, what we can say, the water. So sustainable drinking water supply is the main motive for which civil engineering studies are required. So here, how resilience perspective will support this particular mission: decentralized water system. So there should be the cutoff in between the various grade. There should be the proper management, control, and operation support at the block level. So decentralized water system will help this particular purpose. Secondly, climate resilient water infrastructure. This is what the requirement, and the reduced vulnerability during the droughts and flood. So these particular three purposes should be taken or should be treated as a benchmark while, yes, designing the Jal Jeevan missions, yes, what we can say, pipeline grid networks. Next, it shifts water infrastructure from centralized and fragile to distributed and resilient system. So try to understand, we have to, just like a survey principle, work from whole to part. So similarly, now we have to focus on the parts, and we have to define and design the Jal Jeevan mission sort of schemes. So the water security is a foundation of infrastructural resilience, not just a welfare goal. So try to understand, during disaster, this is nothing but the very important resource, and for that there should be a, yes, solution in terms of the water security, and this is one of the foundation for infrastructure resilience. So in any disaster, if you could able to help the society with this particular 24/7 water supply, definitely the impact of the disaster will be, yes, damped very greatly. Next, PMGS5 phase 3, climate resilient road. Yes, we have studied so many road designs. Okay, there are so many expectations from civil engineers related to the road. Many a times, whenever there are potholes, whenever there is a bad quality roads, the civil engineers are nothing but the main target, and they are supposed to be recalled so many times by the road user. And why it is happening? Because here we are not taken into account the climate resilient rural road networks. We are not taken into account the connectivity that survives under the floods, landslide, and extreme weather. So this is nothing but the parameter we need to study, which focuses mainly on improved drainage. I have already told you, we are teaching to the student that drainage should be there alongside with the road, but at an actual on grounds, the drainage lines are not available. Better pavement design, there is a scope. On tomorrow morning there will be a session by Dr. Sangram, so he will be focusing on these particular parameters. All weather connectivity should be there. So this reduces isolation of the rural areas, delays in emergency response, and economical losses during the disaster. So my dear friend, resilient roads are lifelines, especially during and after the disaster. So the resilient roads are one of the important parameter. There is a great reduction of disaster impact on the society if there is a proper communication, not only in terms of the road, but also the telecommunication, satellite communication, every sort of communication. So these are nothing but the blood artery in human bodies. So they are treated, they supposed to be treated as a lifeline. And specifically in the resilient infrastructure, the climate resilient roads are nothing but the very important, yes, thing. And this is an opportunity for us to develop such a sort of roads. So India already has the policies and mission required for the resilient infrastructure. The opportunity lies in leveraging, integrating, and implementing them effectively. So this is nothing but the part and parcel of all the civil engineering government officials. Okay, because they are the policy makers. There should be the integration from the research domain with the actual ground practices, and there should be the proper implementation of these practices on ground. So our biggest opportunity is that resilience is already embedded in the India's development policy. It is already there on a piece of paper. We now need to convert them into the intent, into the impact. That is what we are in need of. Now see, there are opportunities. I have already told you now we are moving toward the part B of the technological opportunities. So there is a GIS and remote sensing, which will be used for flood zoning, landslide susceptibility mapping, infrastructural vulnerability mapping. There is a AIML application. I have already told you there should be emphasis in learning and teaching the various languages. So AIML application, failure prediction models, this is the need of time, predictive maintenance, early warning system, and risk informed planning. This is nothing but the gray area where we are lagging. The digital twins, the cities, bridges, water networks, they're supposed to be, yes, created, drafted, and they're supposed to be simulated, validated on, yes, what we can say, the computational facility, and then they're supposed to be created on the actual ground. So the scenario based stress testing sort of things are need of time. So we will discuss one by one. The GIS and remote sensing. Now see the flood zoning. The GIS and satellite data helps identify the flood prone zones that I have already shared with you. The NRSC has prepared that particular atlas. Inundation depths, flood frequency and extent. This can be extracted from the GIS. Now, what will happen if you could able to study such a sort of things way before designing the maps? So it enable us to risk informed land use planning. It enable us for safe siting of roads, bridges, and settlement. So the site selection will be very easy. So it supports early warning and evacuation planning. So in nutshell, we can say the floods cannot be prevented, that is for sure, but their impact can be minimized through spatial intelligence. So the spatial intelligence is much important in line with, yes, the GIS or we can say the RAGIS studies. Next one, the landslide susceptibility mapping. We all are aware that there is a one compulsory subject, engineering geology. Nowadays, why the various autonomy practices they are neglecting the engineering geology, I don't know, but it is nothing but the heart of the civil engineering. So whenever there is a terrain study, slope, geology, rainfall, land cover, and satellite imagery, these particular things needs to be studied in detail. This is supposed to be used in detail. When we are talking, hello, when we are talking about identifying the risk susceptibility, there should be the categories, there should be the classification on the basis of the susceptibility, high, moderate, and the low risk zones. And that will help us in highway alignment specifically. That will help us in understanding the slope stabilization and the measures required in priority basis. So there will be a no change in the project cost. Many times the slope stabilization, whenever we are cutting the slopes, there is a requirement of the slope stabilization as well. As we are not treated, we are not considered that particular point into well in account into our what we can say monetary aspect. Afterwards, the project viability will not be there, and that's why the slope stabilization prioritization is much important. At the end, avoiding the high risk construction zones is again important parameter, and that we could able to well aware way before if we could able to study that susceptibility mapping. Now, see, when we are talking about the landslide, they become disaster mainly due to the first, the poor site selection, and second, due to inadequate slope management. So these particular two parameter needs to be studied well in advance for resilient infrastructure. Now, coming to the next parameter, infrastructural vulnerability mapping. Now, see, it combines the hazard data with location of the roads, bridges, pipeline, power lines, buildings. It identifies the critical assets at risk and weak links in infrastructure network. So, infrastructural vulnerability mapping is the area which has not been touched by many researchers. So, if we could able to understand the available infrastructure which is there, which is existing, how it may become vulnerable, what will be the impact at the end of the disaster, so that we need to understand. After disaster, how we could able to retrofit it, maintain it, how we can able to plan for the emergency things during that particular disaster, that is again the important study needs to be done. So the resilience improves when we know which asset matter most and where they are most vulnerable. So this is very much important in nowadays scenario. Now see the next point, AIML applications, the failure prediction models. Here we can say the shift from the fail and repair to predict and prevent. So AIML, they will definitely help us in many sense through the sensor data, historical failure records, environmental parameters. Okay, so that's why we are in need to understand the long range database, and this can be very easily understood by using the AIML model. Next, predict potential failures. So we could able to identify the failures of bridges, pavements, slope, water and power system well in advance with the AI and ML application, and that is what the need of time. I hope I'm audible because there was a outage of the power.
Yes, sir. Yes, sir. Yes, sir.
Thank you. Thank you.
Audible.
Next point, the predictive maintenance. See, the uses of real-time monitoring and AI analytics. So this will enable us to maintenance before failure occurs. This will help us in reduce downtime and cost saving over life cycle. We all are aware that main material machinery money. Above that, the time is the very precious resource we civil engineers supposed to respect, and that is nothing but this concern related to the predictive maintenance. So the preventive action is cheaper and safer than the post failure reconstruction, and that is what we need to understand. So the infrastructural maintenance, the predictive maintenance should be done, and for that we could go with the AI analytics. Then early warning systems. AI integrates so many databases together. They are preparing the so many layers, they are analyzing it for us. So the rainfall data, river levels, ground movements, all this particular study can be done with the AI. This will provide definitely the timely alert for the flood, landslide, and the infrastructural failures. So the minutes of the warning can save the lives and infrastructure. There is one particular slogan: "Stitch at a time saves nine." Similarly, early warning system with the good or the ample amount of the time available for the evacuation will definitely save the lives and properties. Next one, risk informed planning. AI driven decision support system helps to compare the design alternative, optimize the investment, incorporate the climate uncertainty. So whenever there is a suggestion of any alternative, any solution in terms of the infrastructure, there should be the comparison. Various design alternatives should be compared. There should be the optimization study. There should be the climate uncertainty taken into account. And so the planning must be the data driven, not the institution driven, and intuition driven. And that is what the very important parameter, because many times we are unable to handle the big data, and this big data handling is the concern earlier, but with the AI now we can able to handle the data at very large extent, and that is what we are in need of. Now next one, the digital twins, the cities, bridges and the water networks. My dear friend, digital twin is nothing but the virtual replica of the physical infrastructure. Whatever we are planning, it is supposed to be observed, it is supposed to be what we can say tested way before it is actually implemented on the ground. So it will enable us to continue continuous monitoring. Hello.
Request all the participants to turn their mics off. Thank you, sir. Over to you, sir.
लोकरे सर, सरांचं
Bobade,
unmute.
sir. Bobade, sir, can you hear us?
Am I audible?
Yes.
Yes, sir. Please continue.
Yes, sir.
Yes, sir, yes.
Okay, so digital twins, this allows the engineers to see the infrastructure behavior before the failures occur, and that is nothing but the area where our students may have the good employment in future. Next, scenario-based testing. Now see the simulations. Yes, the extreme rainfall, earthquakes, traffic surges, climate change impacts. This will definitely help us to test the infrastructure response before real disaster happen. So scenario-based stress testing is nowadays very important, and this will avoid the real world failures. So this is nothing but one of the opportunity with us in terms of the technology. So technology gives India the opportunity to leapfrog from the conventional engineering to intelligent, resilient and the infrastructure system. So in nutshell, we can say the resilient infrastructure in the future will be built as much with the data and the algorithm as with the concrete and steel. So this is needs to be understand. We need to adapt with the change, because now this is the era of the digitization. So data and algorithm is as important as our concrete and steel. Now, when we are talking about the opportunities, is these are some pictorial, what we can say, the explanation of earlier discussion we have done. So GIS and remote sensing for flood zoning, landslide susceptibility, infrastructure vulnerability, AIML and digital twins for failure prediction, predictive maintenance, early warnings, and stress testing. Now the next one is nothing but the nature-based solution. Okay, so we will discuss this with the pictorial view only because of the lack of time. So see, nature-based solution. The very first is bioengineering slopes. So try to understand, whenever we are disrespecting Mother Earth, whenever we are cutting the road, going for the cutting for the roads or any other irrigation project through the ghat section or anywhere on the earth, definitely the slopes are become unstable, and that is why there is a need nowadays the bioengineering slope. So bioengineering slope, there is one particular grass, vetiver grass, which is having the very deep roots, and they are holding the soil mass very tightly. So such a sort of bioengineering slopes needs to be planned while going for the resilient infrastructure. Wetlands for flood mitigation. My dear friends, see this particular picture, this particular slope in terms of the contours. Okay, they have cut down, and here on this particular slope we are having one solution called as bioengineering slopes. Now this is the wetland. Earlier in the villages, in the urban area, rural area, everywhere, there was one particular area, low-lying area, having the good permeability, and it's supposed to withstand with the excessive water. But nowadays, in terms of the grid, in terms of the progress, we people are not respecting the Mother Earth, and we are utilizing such a wetlands for the infrastructural development. But if you could able to still able to give the wetlands availability for flood mitigation, definitely that wetland will about to reduce the stormwater flow. There will be a less stress on the stormwater design and drains, and that is what the need of time. At the end, the urban green infrastructure, there should be the corridors, green corridors, so that the at urban area also the people would like to enjoy all the sustainable development goals. They could able to just share these resources with the coming generation very effectively. So these are some typical, what we can say, the nature based solution we need to follow. Now moving ahead with the case studies, we all are aware that Mumbai flood in 2005 versus the recent improvement in 2025. The very first, the drainage redesign was there. Whatever the natural drains were there, they were already covered by the, what we can say, in the grid of the uh, progress, and that is the reason the Mumbai is always experiencing the flood. So drainage redesign is one of the parameter. Pumping stations, there should be the proper pumping station location. They're supposed to pump the water, and they're supposed to release in the drains from where it will be easily moved towards the sea. And GIS based flood modeling should be there. So see, when we are talking about the 26th July 2005, which is nothing but the darkest reminders of the infrastructure failure in India. Why darkest? Because during that particular day itself, we experienced 944 millimeter of the rainfall, and because of that, the city was become the what we can say devastating or the vulnerable during this particular 24 hours. So here we can see, when we are talking about such a sort of concerns, the very first concern was outdated drainage system, which was designed for 20 millimeter per hour rainfall, and we have experienced the 944 millimeter of the rainfall in 24 hours. Now try to understand, there is a great gap in between 25 and 944, but still at moderate level we could able to design the drainage. Completely inadequate for extreme events, that we all are aware, but as economy is the another concern, we have to go for the moderate solution. Choked by the solid waste and the encroachment, this is nothing but the gift from our end to our side, and that is what needs to be understood. Loss of natural buffers, destruction of the wetlands and mangroves, reduction natural flood storage capacity. This is again done by the human intervention, and that is what needs to be studied way before suggesting any infrastructural development. No real-time flood intelligence, absence of flood forecasting, no special flood maps for the decision support system at that time were available in 2005. Nowadays they are working with the flood forecasting and the maps are ready for the Mumbai, but still try to understand these are nothing but the concerns. So the disaster was not only due to the rainfall but due to the infrastructure that failed to adapt. So we are not at all ready to just adapt with the changes, and this is nothing but the concern behind the failure. Now recent improvement, what they did, what BMC did rather, so Brihan Mumbai storm water drainage project was taken into account consideration, and they increased the drain capacity first. They regularize the desilting and maintenance. They are doing the maintenance very properly. Integration of stormwater and outfall improvements was there. Secondly, the pumping station, the high capacity pumping station at low lying areas, they have planned, they have installed that particular pumping station over there. Ability to discharge the water even during the high tides, this was again studied very thoroughly, and it is working very smoothly nowadays. Faster recession of flood waters compared to 2005. So that is what they did. Now, in line with the RHGIS, what they did is real-time rainfall monitoring was started for Mumbai city, flood inundation maps, identification of vulnerable zones, decision support for disaster response. And now see, the engineers and planners now see the flood before it happens. They are in position to understand the tragedy. They are in position to understand the disaster. And because of that, now the recovery or the support from the BMC was very well advanced. Now, next point, what this case study teaches us, the very first technical lesson is resilience is not about the preventing the flood, but about ensuring the cities continues to function during the flood. So this is the technical lesson we can say. Human lesson, behind every infrastructure failure are real people, real families, and real suffering. So this is nothing but needs to be understand. And at the end, policy investment in resilient infrastructure saves lives, not just money. So try to understand, here we need to invest into resilience, not into the infrastructure. So why this case is important for civil engineers? Because reactive disaster response to protective risk management, this is what we need to understand in terms of the shift from response to, yes, protective risk management. Here shows how engineering, technology, and the governments must work together. And at the end, it reinforces the responsibility of the engineers as the protectors of the public safety. Now, Mumbai 2005 reminds us that when infrastructure fails, humanity suffers, but when infrastructure learns, city survives. So that is what we need to learn from the infrastructure, why they are not able to serve the purpose, and we have to give the solution to that. So this is what one picture I have prepared. So using AIML, so turning past tragedy into the hope and resilience for the future. So this is what the need of time, the storm water, the pumping stations, the use of the RGIS, RHGIS rather, the engineers, so that there will be the smooth functioning of the city afterwards. So Himalayan roads and landslide. Okay, as I think I'm crossing the timeline, so I will cover it so fast because I have an opportunity afterwards as well, where I could able to cover these points again in the session number 10. So see, resilient infrastructure is not an option for India; it is the national necessity. So in Himalayan roads, they don't fail because nature is harsh. Very simple understanding till date from the Himalayan. They fail when the engineering forgets to respect the nature, and that is what happening every time. And so when we are talking about the resilient infrastructure, so this is what concern related to the Ghat section roads, because they are not respecting the Mother Earth. At the same time, they are not ready with the maps. Okay, disaster maps, vulnerability maps for the landslide, flood, or anything else. And without having such a preparedness, they start constructing the roads, and that is what they are, yes, suffering from. So here the losses of the lives and the, yes, properties are more, but when we go with the respect towards the Mother Earth, definitely there will be less losses. So when road fails, human lives are shattered. When road adapts, they are safeguarded. So this is what we need to learn through the Himalayan roads and the landslide. So Western Ghat, Western Maharashtra. Quickly, I would like to show you the one presentation. Now try to understand this. This was the concern from Western Maharashtra. On 30th of July 2014, there was one landslide at Marine. During this Marine landslide, there was one particular interview, okay, shared on the ABP Maza, and this was recalling the memories of 26th of July 2005, when the landslide was happened at Dasgaon, okay, at Raigad district. Now try to understand, these are nothing but the economic losses, poverty and disaster since so many times continent-wise economic losses. Now see, this is the major landslide prone at area of the India. This is what scenario the retaining structures are. They are not able to withstand with the surcharge masses because they are poorly designed. This sort of very heavy costly solutions at Konkan region we are observing nowadays. These are the concerns in real time sense. When we were traveling to that particular Ghat section, we came across so many disastrous location. Now see the vulnerability related to this guest house. At the same time, the road, newly constructed road, was wiped out with the one single rain. This is the concern related to the Konkan railway, where the landslide is happening, and the only solution was to cut down the complete hillside into the trenches. Bunding is required. So when I talked with the design of chief engineer of design wing of the bridges, engineer Ramgude Sahib, and engineer Satpute Sahib, the SCPWD. So I got an idea that how we could able to sustain sort of disaster in future. So this was my actually the topic of the PhD. I would like to only show you the methodology I have adopted during that study. So problem statement was very simple, that the landslides to be mitigated with the economical way. So study of characteristics, properties of soil. So geology, geotechnical engineering was required. Morphometric analysis, drainage pattern change. Geography is required because I need to study the drainage network. I need to study the drainage change analysis over the period of time. I need to study the effect of runoff. Then I have applied the SWAT, the hydrological modeling, soil, water, and analysis tool. So model selection was very important because I am interested in subsurface water study. So model setup, calibration, validation of methodology was required. Then at the end, I have prepared the landslide susceptibility mapping by having the expert opinion from Dr. Kumtekar sir, Professor P.K. Deshpande sir. We have understand few parameters, we have given the some weightages, and we have prepared landslide susceptibility map for validation. And at the end, I have recommended for cost-effective mitigative measure. So this was the study. Okay, so this was the database we have used during that particular study. This was the geotechnical test. Okay, this was the study of the characteristics, properties of soil. I came to know after this that the soil is very impermeable. And during this particular study, I have studied first the Raigad district and then Ratnagiri district for the validation. So present study for Raigad district and for validation of my hydrological model setup and landslide susceptibility mapping for Ratnagiri district. So here, this was the morphometric analysis methodology. Okay, linear aspect, real aspect, and relief aspect has been studied using the two-time data set, one from 1967 when there was only toposit available for the study area. So I have prepared from that particular toposit the DEM, and the Alos Pulsar DEM from 2020. I have prepared this particular drainage pattern analysis. So there are elevation, slope, flow direction using various DEM has been studied. Okay, then this was the concern, the drainage pattern for threshold of 5 square kilometer for the study area. How I could able to come to the 5 square kilometer, because I have studied the study area starting from 50 square kilometer up to 5 square kilometer. I got good what you can say resolution, and the drainage network was clearly seen up to the 5 square kilometer. So I went with this option. So this was the assessment of the drainage changes. See, for 1967 till 2020. So 1967 and 2020 clearly seen that the first order drainage has been drastically reduced. So number of drainage reduced means what? Where that water will go? It will go underneath the ground. It will just emerge out when it got some access. Always anyone would like to freely, what we can say, move here and there. The same is with the water. Water would like to just come back at the atmospheric pressure without any, what we can say, the restriction. And so here clearly seen that the first order, second order, third order, fourth order, 5th, 6th and 7th, as Savitri watershed is 7th order. So we can clearly see that at 7th order, how the length of the river has been changed. So through this particular study, it has been clearly seen that this particular 1967 versus 2020, here we can able to see the change in terms of the drainage lines. So this is nothing but the number of streams. See, in 1967, first order was 7752. In 2020, first order streams was 3134. By understanding this study, I came to know that now there is a need to study the morphometric analysis. So drainage density, how it has been changed, stream frequency, how it has been changed, absolute relief, relative relief, slope map, hypsometric curve. So everything has been studied, and after that, the SWAT hydrological model was decided to be set for this particular area. Now, this is the methodology for SWAT hydrological model, and in SWAT hydrological modeling, I have studied the two case studies where the retaining structure has been failed, one at Dasgaon and another one at Lower Tudil and Zui Budruk, where in 2005 the great losses of the lives were occurred. So I have studied the hydrological modeling. Using this, I came to know that after calibration in a hydrological study, R square value up to 0.6 seems to be fine for going ahead with the research. So calibration was done for 2003-4, validation was done for 2005, and here I came to know that the Dasgaon precipitation, it has been observed very high during the June-July. And during this particular point, the soil has just reached the its moisture capacity, and afterwards whatever the available water is there, it is about to flow freely. That might be the surface drainage, that might be the subsurface drainage, that might be the lateral drainage, that might be the water yield, and that might be the sediment yield. So I have studied this for yearly, for two different basins. The sub basin 71 for Dasgaon, second one 96 for the Lower Tudil. After that, we have seen the changes in terms of the percentage change, average yearly, percentage change, maximum value. And here we came to know that, yes, the similar trend was there. In July, the precipitation was high. In July, the soil losing the water freely because the soil moisture has been attained. And similarly, the various discharges has been added. So surface discharge, subsurface discharge, lateral discharge, they have reached their limits. And because of that, there was the great poor water pressure behind the retaining structure, and that's why the retaining structure has been failed. So these are nothing but the case studies for the June-July for the specific month. The incident was observed to be in terms of the retaining structure failure was in July, so it was been studied. Validation, how we could able to validate any study. So as I have did the study for the Ratnagiri district, now for validation there should be another district having the similar sort of what we can say the phenomena. So I have chosen the Ratnagiri, where the Konkan railway is facing so many concern related to the its movement during the monsoon season. And so the Pomende and Newsar station were studied, where the retaining structure has been failed. So you can clearly see this much of the area has been failed through the landslide. So calibration validation was done. The value was in what we can say expectation range of 0.6 R square value. Averagely studied, the SWAT hydrological model set earlier shows the similar trends in terms of the precipitation. Once the precipitation was very high, at that time the soil moisture start losing the free water, and this free water in terms of the various forms, it is available in terms of the discharge. And this is nothing but the concern related to the failure of the retaining structure. So in both the cases, I observed that this incident was happened in June. Earlier incident at Ratnagiri was happened in July. So though there were the different incident happened in different month with the different location, but the hydrological model setup shows that yes, it is related to the drainage. Now KRCL, Konkan Railway Corporation Limited, also prepared one report related to the failure of that particular retaining structure, because such a retaining structure has been constructed using their own codes, railway codes. And here they have clearly mentioned that the provision of the drainage through retaining wall was not appropriate, and the concern was related to the drainage only. Now try to understand. I have studied further for the precipitation, soil water, sediment, charges for this particular studies, and compared with the Ratnagiri district, Pomende and Newsar basin, and I came towards the understanding that there are some particular factors needs to be studied in detail. So I have prepared this particular methodology, keeping into mind some typical parameters needs to be studied for the landslide susceptibility mapping. So these are nothing but the methodology for AHP, and these are nothing but the various parameter according to the SATIS study. So the scales and degree of preferences, these are the various categories or the parameters that needs to be given particular weightage. So I ranked one, the rainfall slope to be ranked second. Accordingly, aspect will be 10, and I have prepared the landslide susceptibility map of the Raigad district. Now see here, the total 2030 villages were there in Raigad district, and out of that there are 5 categories: very high susceptible zone, high susceptible zone, moderate, low susceptible, and very low susceptible zone. This has been nomenclated with the color coding in this particular map, and again it is validated for the AUC, area under curve, and here we can clearly see the area under curve. Here the true, false, and false. Okay, this is nothing but the true positive rate, and this is the false positive rate. As true positive rate has been the 90+%. So this methodology, this map was prepared by considering the weightage assignment to the various parameter has been very accurately mapped. So this is the one study, part 2. The third study is nothing but innovative mitigative measure. Now see the earth retaining structure. We already known that whenever there is an earth retaining structure, once it is moved, once it is shifted, once it is overturned, it is none of anyone's business, and we are losing the monetary investment into it. But with the innovative concept like H and Y block, with the H block we could have the 45-degree angle, and with the Y block we could have the straight alignment of the retaining structure. By considering this, we have designed this particular innovative patented earth retaining structure, and I have constructed this as a pilot study near the Pratapgarh Fort, okay, at Ambenari Ghat, from where the bus has fallen into the valley. So PWD Maharashtra sponsored my study, research study. They invested up to 4 lakh, and I could able to construct the retaining structure over there. So this is nothing but the precast one. So quality will be very high. We could able to construct this particular retaining structure very quickly. Drainage, this particular channels, upper channels will allow me to drain the water very easily. Easiness, it is very easy to assemble. Quality, yes, as it is prepared at the casting yard, so quality will be taken into account. Production is very high, because during rainy season also under the shelter we could able to construct it, create it, produce it, sorry. So production rate is high, speed is high. Secondly, as we are constructing the earth retaining structure, we need not need to stop the transportation system. Okay, so the time economy, less mechanism and equipment, less effect on moving traffic, everything has been taken into account, and we have constructed, we have compared it in terms of the economical analysis also, and we found that this particular solution is very what we can say, cheaper than other conventional options. So this has been constructed at Ambenari Ghat. Okay, so when we are talking about this, during this particular study, I have been called to present this technical success story at Indian Road Congress 2022 at Lucknow. So this is what we need to study in what we can say, interdisciplinary approach. And so when we are talking about the human intervention at the end, the Ghats don't fail us. We fail the Ghats when we build without listening to the land. So this is what we needs to understand. So AI, GIS, terrain wisdom, these particular points needs to be understand well in advance. So this is the Western Maharashtra case study. Okay, so the similar study I have done, the hazard risk, okay, then slope stabilization efforts with the cost effective mitigative measures. So this is the concerns. Now we will discuss the last 2 slides. The role of academia is very important. I think that the translational research should be there, policy linked studies should be there, live projects with the government agency should be taken by the student. So this is our responsibility. So there are so many, what we can say, the opportunities, okay, required skill set for and upgradation from the faculty, from the students. We are in need of terrain analysis, slope stability, hydrology, GIS, then the core engineering, monitoring system, spatial modeling, AI/ML, data science, policy and resilience planning. Everything needs to be taken into account. Role of the R&D and young engineers, like the budding engineers. So data driven thinking should be there, sustainability and resilience mindset should be there, multidisciplinary approach should be there. So the future civil engineers will be risk managers, system thinkers, and technology integrators. So see, you have to manage the risk nowadays. Now everything has been proven, you have to deal with the risk which is unattended area. So these are the skill set required for the young engineers, like yes, ArcGIS, QGIS study, 3D, civil 3D, StatPro, HECRAS. Okay, what not is there? Everything is available. You need to go with this particular skill set: Python, MATLAB, simulation, visualization, cloud performs, and ANSYS, AIML. Everything we need to now integrate with our conventional civil engineering study. Way forward and conclusion. Okay, so we all together stand together. Okay, so government agencies, industries, and academia, we all needs to be stand strong, and we supposed to think for resilience, hazard free, climate adapting infrastructure for the future. So thank you so much for your patience, full listening, and bearing me for more than 2 hours. Okay, so if there are any questions, I would like to answer it. So resilient infrastructure is not an option for India, but it is a national necessity. That's what we need to understand in detail. Okay, thank you so much. Thank you once again to the organizing committee for giving me an opportunity. Thank you so much.
Yes, sir.
Over
Thank
to
you,
you.
sir.
Thank you.
At this point, we would be happy to take questions and feedback from the participants. So any questions or feedback from the participant?
That was an excellent session, sir. We have been very much benefited from this.
Thank you so much, sir.
Okay. So once again, thank you, sir, for
Thank you
your
so much.
insightful and thought-provoking session. On behalf of organizing team, I sincerely thank you for sharing your valuable knowledge and experience. I also thanks all the participants for their active participation and intersection. We now look forward for the next session, and for next session, one announcement is there. The next session will be on the separate link, and link will be provided before 10 minutes. Session start at sharp 2 p.m. And our next speaker is respected Dr. Shobhit Saxena. He is from University of Leeds, UK. So again, it is one of the interesting session. So all are requested to attend. Once again, my friend Dr. Bobade sir, thank you for giving time and
Thank you so much.
giving your spend your time and give your experience and knowledge to our participant and us. Thank you very much. Now I declare this particular session is over, and next session start at 2 p.m. So all of you join the next session. Thank you. Thank you very much.
The next link will be provided 10 minutes prior to the commencement of our second session. The link will be provided in the WhatsApp group only. So I request all the participants to join the second session at sharp 2 p.m. Thank you. Thank you so much.